Welcome everyone to BTT 151 Fundamentals of Electricity. I'd like to introduce your Unit 6 concepts on parallel circuits. So please remember, last week we talked in Unit 5 on series circuits. So remember, in a series circuit, to solve for the equivalent value of resistors connected together, whether there were two or more, you simply add up all those values. We talked about things like R equivalent, remember, was equal to R1 plus R2 plus R3 plus R4, the values of those four resistors in a series circuit. The current is the same through each of those resistors in a series circuit, but the voltage drops will vary. And the sum of those voltage drops that we identified as VR1, for example, voltage drop across R1, VR2, the voltage drop across R2, VR3 and VR4, simply add those numbers together and they have to equal the actual source voltage. Well, this week in Unit 6, when we evaluate parallel circuits, we're going to look at a different type of circuit. So in a parallel circuit, notice I still have a battery with positive and negative polarity, plus and minus signs as you see, but in this example I have three resistors connected in parallel, R1, R2, and R3, and some new terms to identify. I sub t is called the total current, and then I1, I2 and I3, these are called branch currents. So in a parallel circuit, the total current IT is equal to the sum of the branch currents, I1 plus I2 plus I3. This time, the value of voltage drops are identical. So pretend if this were to be a 12-volt battery, I would drop 12 volts across resistor 1, I would drop 12 volts across resistor 2, I would drop 12 volts across resistor 3. So in effect, whatever that battery voltage is going to be the same value of voltage across each of the three resistors connected. Two new expressions to look at when we connect resistors in parallel. If I only have two resistors connected in parallel, R equivalent now becomes R1 multiplied by R2 divided by R1 plus R2. And again, that's only for two resistors in parallel. If I have more than two resistors connected in parallel, R equivalent is equal to 1 divided by 1 over R1 plus 1 over R2 plus 1 over R3. How many resistors are connected in parallel would follow that same algebraic expression. So in a parallel circuit, what we're going to be looking for are the three branch currents, I1, I2, and I3, and using Ohm's law, I1 is equal to VR1 divided by R1, I2 is equal to VR2 divided by R2, and then I3 is equal to VR3 divided by R3. Once I get each of those individual branch currents, I1, I2, and I3, I can simply add those back together to be equal to that total current. So please take a look at your Unit 6 text on parallel circuits. Review the PowerPoint presentation. I will have a video from the engineering mindset on how to do calculations. Have a great week, everyone.